the floor. Okay. Is in this format. So a Bernoulli differential equation looks like this. It will have, you will be able to get it in this format, dy over dx plus p of x y equals f of x times y to the nth power. All right, so the difference here is this right side of the problem. You can't just get some function. If in a linear differential equation, this was called q of x, this whole side, and it was just a function of x. But in a Bernoulli differential equation, you're going to end up with y to some power over here. Okay, so if n is 0, then it's a linear differential equation. Obviously, because there was, what's y to the 0 power? 1, so there's no y over here. There's no y over here in a linear differential equation. And if n is 1, then it's separable. Okay, if this just had a y over here, then it would be a separable differential equation. But it's not. It's going to have y to some power other than 1 or 0. So in this case, a Bernoulli differential equation, we're looking at the cases where n is something other than 1 or 0. So what our goal is to make this into a linear differential equation. Okay? Our goal is to make this into a linear differential equation, and we do that through a substitution, and that substitution is v equals y to the 1 minus n power. So your substitution in a Bernoulli differential equation you're going to start with this substitution. Okay? V equals y to the 1 over nth power, and what you're going to do are format to the linear. Okay, so when you're solving a differential equation, whether it's linear or Bernoulli, or maybe you don't know, okay, this would be a general format you could get it into. From this format, this over here will tell you whether it's a linear, if there's no y. It will tell you if it's separable, if that's just y to the first. And if it's not, then it's Bernoulli, and we have to follow this strategy. So we're going to let v equal y to the 1 minus n power. So whatever that power is what goes here. We rearrange this, find y and y prime, and substitute y and y prime into our differential equation. So then what we should have after that, now we should have a linear differential equation. And then we can go through and find the integrating factor and work it out like we did these. So a Bernoulli differential equation, we need to use a substitution to turn it into a linear differential equation. So let's take a look at one example. All right, so is this in the right format? Yep. Is it okay to just leave the y prime as y prime for the moment? It is. It is. Well, I mean, do you want to add more steps purposefully? No, it's not necessary. We can do a couple things at once. I know that this is not linear because there is a y squared there. I know that it's not separable because it's not just a y. So I need to use my substitution. What is n in my problem here? N is the power on that y at the end, so n is 2. So my v is going to be y to the 1 minus 2 power, or v is y to the negative 1 power. Okay, what this substitution is going to do for our differential equation is change it into a linear differential equation. Okay? So now, what do I do with that v problem? What did I tell you in our strategy? What do we do with this little equation now? Get y alone and find y prime, and then use both of those things to substitute into our differential equation. So y is, oh my, how do I get y alone there? Isn't v, no, it's y to the negative 1. Isn't this the same as 1 over y? Isn't that y to the negative 1? So multiply by y and divide by v. What does y equal? 1 over v. So now y prime negative 1 over v squared times dv over dx. The derivative of v in terms of x. V is like, we're at its implicit differentiation there. Alright, so now I have my little substitution things that I can plug into here. Y prime, isn't that's dy over dx, right? Okay, so in place of this y prime, I'm going to put negative 1 over v squared times dv over dx. So this is my little substitution step. There's my original differential equation. Plus x times 1 over v equals x times, what's going to go in for y squared? 1 over v squared. Because y is 1 over v, square it, 1 over v squared. Alright, so now what we should have here is a linear differential equation. I'm going to have to get it in the correct format for my linear differential equation. It's the difference is I'm not dealing with dy over dx, I have dv over dx that I'm going to be dealing with. Okay? And then I'm going to also throw in my integrating factor too. So what should I do to get this in the right format for the linear differential equation? dv over dx needs to be by itself, so what am I going to have to multiply everything by? I'm going to multiply the entire thing, both sides, by negative v squared. So I get dv over dx. Okay, multiply this by v squared. I'm going to get minus vx, xv, equals negative x. Yes? Okay. So what is my integrating factor here? I need to find my integrating factor now. Okay, this is linear. Now, linear differential equation. What is my p of x? P of x is not x. It is negative x. So I want to find e to the integral of negative x dx. This is the antiderivative of negative x. No. Power rule. Negative x squared over 2. So e to the negative x squared over 2 is my, what? Integrating factor right there. There's my IF, my integrating factor. What do I do with that integrating factor now? Multiply both sides of my differential equation. I'm going to rewrite the whole differential equation on the next piece of paper. So I have dv over dx minus xv equals negative s. I'm multiplying that whole thing by e to the negative x squared over 2. So the left side, remember I'm just going to write, not even going to multiply it out. I really don't want to have to think about two integrals, okay? I'm going to integrate that side, which I should already know that antiderivative. I should probably put the screen so you can see what I'm writing, huh? So here I just recopied my differential equation, the one I made into linear. I multiplied by my integrating factor. I'm going to integrate the left, and the right side I have the integral of negative x e to the negative x squared over 2. So what's this antiderivative going to be on the left? Very good. Y times the integrating factor. That's always the antiderivative of the left. It doesn't matter. Okay, now this side, what am I going to have to do for that integral? Question, ladies? No? Oh, yes, it would be v. Y is v in this case. Yes, y is v. Thank you. V e to the negative x squared. Yes, it is the y. You're right, Chase, when you say that. But in our case, the y is v. Okay, so v e to the negative x squared over 2. What do we have to use for this antiderivative? Sam Kuhn, what do we use? What is u?
Negative x squared.
Good. Du? Does this work out nice? So I have the integral of what? E to the u du. What's that antiderivative? E to the u, Ru was negative x squared over 2 plus c. All right. Okay, let me get that down here so we can see it. Okay, so this is what we have. What are we going to have to do now? Okay, get v by itself. You know what, before I get v by itself, don't I need this in terms of y and x and not v and x? So what was v to start with? V is 1 over y. So isn't this the same as 1 over y times I'm really good at that today. So now if you were trying to get y by itself, what might be a good strategy here? You're going to multiply everything by y? Yeah, we could do it that way. Although aren't these two technically on the bottom right now? These e to the exponent things? So, I mean, I don't know, we could go through a bunch of steps to try to get this a certain way, but I might just, I don't know. Here's what I'm going to do. I'm going to leave this as 1 over y for now. I'm going to divide both sides, both parts by this. Kind of like we would have done before, right? Okay. So I'm going to divide by that. So what's this divided by e to the negative x squared? 1. So we'll have 1 plus c actually no, I'm just going to leave it like that. E to the negative x squared over 2 plus c all over e to the negative x squared over 2. Okay, so I have 1 over y here in this fraction here. What if I take the reciprocal of this side? What should I do to that side? Take the reciprocal. Can you take the reciprocal of both sides? Yeah, you can. So you could leave it like that. Another option, I guess backing up something else you could have done.